What I want to do in this video is presenting some simple animation that can help us to have a better understanding of a unit circle and how we can use a unit circle to study cyclic function and also graph them. Here we're going to use a unit circle to study two cyclic functions, sine of theta and cosine of theta, in a full cycle and see how these two behave in different part of a full cycle. A circle is a perfect cyclic function, and in a unit circle we relate right angle triangle and the coordinate system to the circle. And using these two help us to navigate through a cyclic function and studying different angle, different position in a cyclic function. Here, in order to analyze the behavior of sine and cosine of theta, we're going to try different angle theta in a unit circle and see how they behave in 4/4 of a unit circle. In order to be easier for us to trace the change of theta and change of sine and cosine of theta accordingly, this dog will go around the unit circle and start from the 0 point here, and we navigate the dog by reading the angle theta, and this woman will position herself at the x coordinate of this dog, which in a unit circle x coordinate is the same as cosine of theta, and this man is going to position himself at y coordinate of the dog, which is the terminal point of angle theta, which is the same with the sine of theta. So when this dog going around the circle and passing 4/4 of unit circle, we can see how cosine and sine of theta are changing by change of the value of theta. Here you can see the dog standing at his initial position, and in a unit circle the initial position is at theta equal to 0 here, and the x coordinate of the dog is 1 and y coordinate is 0. So this woman is standing at x1 and the man is standing at y0. You can see here this woman can move on a x-axis and go from +1 to -1, and she cannot take any other value than x between +1 to -1. So that's a way that we define the cosine of theta and the value that it can have. And this man can move from +1 to -1. So y would be between these two numbers. The sign can go from -1 to +1. The dog start moving and theta will increase. As this dog going through this quarter, which is the first quarter of unit circle, this lady start going toward the origin. So sine of theta going from +1 towards 0, and this man start to move away from the center and going toward y +1. So in the first quarter, sine of theta going from +1 to 0, and cosine of theta going from 0 to its maximum +1. So both sine of theta and cosine of theta are positive in the first quarter of unit circle. Now the dog going to proceed to the second quarter, and this man and this woman going to follow him. So in the second quarter, Miss Cosine moved from origin to -1, which is her minimum value here, and Mr. Sine coming from +1 to 0. In this quarter, the value for Miss Cosine was minus because she is in the negative part of the x-axis, but the sign is still positive here. He just in the first quarter he went up, and in this quarter he came back here. So sine is positive and cosine is negative in the second quarter. The dog or Mr. Theta moving again, and he goes from a coordinate of -1 and 0, and he proceeds to the third quarter, and theta is increasing again, and these two also following him. Miss Cosine start to move back toward the origin, so she goes from her minimum value -1 to 0, and Mr. Sine moving away from origin again, and he goes from 0 to his minimum value. As we saw, Miss Cosine and Mr. Sine, they both have the negative value in the third quarter. She was in the negative part of x-axis and he was in the negative part of y-axis. So both sine and cosine are negative in the third quarter of a unit circle. Mr. Theta moves again, then this time he goes from -1 and 0 to his initial position. When theta changes, the value of sine and cosine will also change accordingly. We increase the theta here. As you saw, Miss Cosine in the fourth quarter of unit circle moves away from the origin and she comes back to her initial position, which is 1, and her maximum value. And Mr. Sine goes from -1 toward the origin and to his initial position. Therefore, cosine of theta has a positive value and sine of theta has a negative value in the fourth quarter of a unit circle. So the dog finishes a full cycle and we saw how sine and cosine behave in a full cycle. And now is the time for graphing the sine and cosine function. So based on what we have, we can now graph cosine of theta in respect to theta. The first thing that we do, we mark the four quarter of unit circle here. So this should be almost like the same length here. Pi over 2 pi, this is 3 pi over 2, and this is 2 pi. I also put sine and cosine tables. So this is the initial position in the first quarter. This is the beginning point of the second quarter. And this is the beginning of the third quarter. And this is the beginning of fourth quarter. And this is the end. And back to the initial position. So I'm going to put this 5 point here. When theta is 0, cosine is 1. So here, yes. When theta is pi over 2, cosine is 0. At pi, cosine is -1. And 3 pi over 2, when theta is this, cosine is 0. At 2 pi is 1. Yeah, so it's here. We can use also these 3 points that it can tell us how exactly this graph would look like here. We have 30° here. Cosine is this. Cosine of theta is somewhere like here. At 45, it should be something here. At 60, which is almost here because this is 90 and this is 60, is almost half. Yeah, half, it should be somewhere here. That would not be easy to draw, but yeah, it should be something like this over here. Just we go down and so this is the x-axis, and as you saw, we Miss Cosine start from 1 and she went here to the 0 and went to -1 and come back here and here. And since theta is also changing, she's not just going on a line, so she has this position, this position, this position, and she come here and going like that. So this is the way that a graph of cosine of theta in respect to theta looks like. The graph for one cycle, and in the next cycle the same shape would be continue. Going to go like this again. So here we do the same thing for graphing sine of theta in respect to theta, Mr. Sine, and the dog. And I just mark this 5 point here and show them here. Now I'm just connecting these dots and seeing how the graph of sine of theta will look like based on what we saw in the unit circle and also the sine and cosine table, the value. Okay, this is the best that I can Mr. Sine at his initial point, he was at 0, he went to 1, back to 0, went to -1, and back to 0, which was his initial position. This is a nicer version of what I drew for you for cosine of theta and sine of theta. You can see how these two functions behave in the four quarter of a unit circle. Whenever cosine is at 1 or -1, sine is 0, 0, because this identity is always true. So if the cosine square is 1, sine has to be 0, and here when we have sine it's at 1 or -1, the cosine is 0. I hope you enjoyed this video, and looking forward to see you in the next presentation.